In this lesson, I have students describe in words what the piecewise function is, meaning before they start graphing it. This one has when x is greater than or equal to 1, that y will be equal to 2x plus 1, and when x is less than 1, y is going to be equal to 1/2 x minus 3. So I teach them to go ahead and just graph the line the way they normally would graph it without the domain being restricted, and then we'll erase the part that they need to. So I have them do this in pencil. And this helps my lower level kids so they don't get so confused about the restriction of the domain. So if you have a y-intercept at 1, and the slope is going to be 2 up and 1 to the right, 2 up and 1 to the right, 2 up, 1 to the right, and then we're going to restrict that domain where it says greater than or equal to 1. So I'm going to go ahead and erase anything that's less than 1, which just happens to be just that point. Everything else is 1 or greater than 1 for the x's. And so now you're going to draw your array on the graph, just a piecewise function there. And then you're going to graph the other one, which had a y-intercept at -3. And the slope is 1 over 2, the ratio, so 1 up and 2 to the right, 1 up and 2 to the right. Or you could have went down 1 and 2 to the left. I'm out of room there where I cut off the graph for the screenshot, but then you're going to erase the domain where it's restricted at. So this says less than 1. So when you get to 1, and you can kind of just use a straight edge and line it up, at when x is 1, that's going to be an open circle. So even though I don't really have a point there, I can use the straight edge and a ruler and erase that, and then I'm just going to put an open circle at 1 where it would line up, because my values for x can go all the way up to 0.99999, all the way up to 1, but not including 1. So you have to draw that line connected to that open circle to show all the points or the solutions for that part of the piecewise function. And then I have them evaluate in the warm-up f of -2. That means that x is -2, so you're going to go to the domain which that would fit into, which would be the second equation where x is less than 1. So you would have -2 divided by 2 minus 3, and that's going to be -1 minus 3, which is -4. And then you'd have 6 plugged in. It would be the one which is greater than or equal to 1, which is the top equation. So that's going to be 2 times 6. And I call on students randomly as I'm going through this, plus 1, and that's going to be equal to 13. And then f of 1 means the x, remember the inside number is that x, and the result or the answer you get is that range or that y value. So 1's going to go in for x in the one that has equal to 1, which is the top equation also. So you're going to have 2 times 1 plus 1, which is 3. And then this time I said, okay, then I had him evaluate. Well, what if I said if f of x is equal to 10? What would the x value be? So if you can't see it on the graph, I know that the top equation is the one that's going to be where x's are going to be, where the y values are going to be positive 10 is going to be in that direction. What's going to be that top equation that we plug into. So this time I'm plugging in 10 for y. So if I had 10 was equal to the 2x plus 1, what would x be? So you would subtract 1 from both sides, and then you would get 2x is equal to 9. And then when you divide by 2 on both sides, x is just going to be equal to 9/2, or 4.5.